We'll start by looking at how you can find, subscribe and download Foursquare data. And when you access the console for the first time, you'll land on this screen, the home screen. From here, you'll have links to services in the middle of the screen, and you can see AWS Data Exchange down here in the Analytics section. You'll have a drop down to access the services, and you'll have a search in the middle of the screen. If we search for Foursquare, you'll see you can now link directly to the 4 of the 19 marketplace offerings. So if we knew the specific product we were interested in, we could go directly to that product and begin the subscription process. We don't today. Instead, we wish to browse the catalogue in AWS Data Exchange. So instead, we'll search for that, and you'll now see the service at the top of the screen. If we select that service, we can begin to explore our data catalogue. If you're using AWS Data Exchange for the first time, you'll expect to land on this screen, and here you'll find various things like links to explore the available data products and buttons to start the registration process for becoming a qualified data provider. You'll also find relevant resources like documentation. To get started, click the menu option over here on the left, and you'll see 3 distinct sections. First, Discover Data Products, My Subscriptions and Publish Data. For discovery, we'll use Discovering Data Products. Once we've found products and subscribed to them, we'll see them in My Subscriptions. And if we're a publisher of data, we'll be able to see our products and our data sets and subscription verification requests in this 3rd section. Today, we'll be browsing the catalogue, so we'll select this option. Now we can see the 3,500 different products in the catalogue. We can see various categories of data. We can see the 220 plus vendors and the 3 different pricing plans that are available on AWS Data Exchange. As we move to the catalogue, we can search for the Foursquare products that we're interested in today, and that will expose the 19 available products in the catalogue. At the top, you'll find some free sample products that can help us get accustomed to working with the Foursquare data, and you'll find below that some paid for subscriptions that companies like Decision Sciences and Yum Brands are building into their applications. We'll select this COVID-19 foot traffic data example to show you the subscription process. Here you'll be presented with product offers. Normally you'll see this public offer, but if you've already engaged with Foursquare, as an example, maybe bringing a license to the platform, or maybe you've got an agreement that started outside of Data Exchange, then you may have a custom offer. Below that, you'll see an overview of the data product with information about how to use it maybe, and its schema. And below that you'll see terms and usage information and how to get support on the product. If you're happy to move forward, you can click Continue to subscribe. Here we'll be asked to complete a subscription request. We'll be provided with information about the product offer, the subscription terms and conditions, the data set, any support information, and we'll have an opportunity to choose whether to renew this subscription at its term. Finally, we'll provide information about our subscription request, and I would provide as full information as you can about your intended use case, as that may help Foursquare provide better and better support to you. At the bottom, I have a blue banner, but that's because I'm internal staff, you won't see this. When you complete and click Send Subscription Request to Provider, you'll see an opportunity to review your subscription request, and you can click Send to Provider. If that's been successful, you'll see a green banner at the top of the page. Once you've made your request, you'll see it in the Subscription Requests section of the platform. Once it's been approved, it'll move to the Entitled Data section, and you'll begin to see it as part of your product subscriptions. Exposing one of my subscriptions. Again, you'll see the same detail, except now you'll have access to individual products within that subscription. Within that product, you'll be able to see revisions. If we select the revision, you'll now be able to see a series of assets. Here we have a single asset, but this could be 10, 20, maybe 100 different assets. If we select the assets, we have the choice to prepare this data with AWS Glue Data Brew, and using that we could maybe prepare repeatable and consistent recipes to transform or normalize this data. Alternatively, we have export actions, and here we can choose to export the revision to Amazon S3, export selected assets to Amazon S3, or maybe download those selected assets locally. I've already done that today, so in a second I'll show you my data in Amazon S3. As you can see, I'm in Amazon S3 and I've now downloaded my Foursquare Places data. From here, I'm going to show you the tools you need to begin working with this kind of data, starting with AWS Glue. Glue is AWS's extraction, transformation and load service, but it's way more than that. It provides governance across your data in the shape of a data catalog, and here you can manage your tables and connections to different data sources and targets like data warehouses. You have crawlers to help infer the schema of the data in these sources and targets, and you have schema registries to help you manage that data. Below that you can see AWS Glue Studio alongside tools like AWS Glue Data Brew. And also there are blueprints, workflows and jobs to provide out-of-box templates to complete any number of different tasks. Finally, there are development endpoints, so your data scientists, as an example, can connect their SageMaker notebooks or their Zeppelin notebook service. We can't yet use our Foursquare data on the AWS platform because we don't know its schema, so the first thing we're going to do is discover that with a crawler. At the top of the page you can see an explanation for the functionality that a crawler provides. If we read along, a crawler connects to a data store, progresses through a prioritised list of classifiers to determine the schema of your data, and then it creates metadata tables in your data catalogue, and that's going to allow you to begin querying your data. So the first thing that we're going to do is add a crawler. Here we're going to provide a crawler with a name and click next. We're going to choose to crawl our data stores and crawl all folders. We're going to choose an S3 data source and we're going to choose our bucket. Once we've chosen our bucket, we can click next. We'll choose not to add another data store, and we're going to use an existing role, but equally you could create one quite simply here at the point of crawling. We'll click next, and finally we'll choose the frequency or how often this is to run, and we'll just run this on demand. Next we get to choose a database, and I'm going to create a new database for this data, and we'll call that database FSQ Data and click create. We'll click next, we'll review the information about the crawler and click finish. Once that's done, we'll find our crawler, which was my new crawler, and we'll run that crawler. Once your crawler is complete, you should see a green banner at the top of the page notifying you of completion and letting you know any changes that it's made. As you can see in this example, it created a table for me and took approximately 1 minute to run. Now the crawler's run, we have our metadata catalog, and we're able to query that data using services like Amazon Athena. And here you can see our data catalog, you can see the database that we created, you can see the table, and you can see the underlying schema of that table. I've prepared a couple of queries here as an example. This one to count the number of records within the table, and we'll just kick that off. And a second query here to extract all of the distinct category names from this data, and we'll run that query too. I stopped the video there because despite these being quite simple queries, just a count and a distinct function, they actually take quite a long time to run, 28 seconds in this example and 37 seconds in this example. And as we want to conduct quite a lot of analytics across this dataset, that's probably not going to be good enough query speeds for our use case. So how can we fix this? So to do that, we're going to move back to AWS Glue, and here we're going to explore jobs. So how can an AWS Glue job help? Well, as it says at the top, a job is your business logic required to perform extraction, transformation and load work. In my particular example, my data is in CSV format, and that isn't particularly effective for query. So what I wish to do is actually optimize this data. And what I'm going to do is convert it from its current format, which is CSV, into a new format, Parquet. Once you've clicked Add Job, you're going to be prompted for a series of different pieces of metadata. The first is a name for your new job. And we'll give that a simple name like My New Job. We've already prepared an IAM role, and this IAM role will provide Glue with the permissions to the data source and the data target. So we'll choose our existing role. Next, we choose some information about the transformation. Here you can see we're going to use Spark, but you get some choice around the different types of transformation that you can make. In this example, I'm going to let AWS Glue propose a script to me. And it's going to create that script under the name My New Job, and it's going to place that script in an S3 bucket that we can choose. Click Next, and you'll be prompted to choose your data store. We can now see my FSQ database, and we can select the Places table and click Next. Here we're going to be asked what we want to do with our data, and today we're going to change the schema. So change the schema of the source data and create a new target data set. So we'll click Next. Our target data set, we're going to create tables in a new target, and our tables are going to reside in Amazon S3. To optimize the format, we're going to convert it from CSV into Parquet, and we're going to choose a bucket I've prepared called FSQ Places Parquet. We'll then click Next. Here we get an opportunity to map relevant fields between our source and our target, and we may wish to do things like change our data types or potentially drop redundant columns if we don't need them any further. Once complete, click Save Job and Edit Script. Here you'll be provided with the auto-generated script, and we can click Run Job to begin that run. Moving back out to Glue, we can now see My New Job, and we can see the progress at the bottom, and we'll come back in a second to see how this got on. That job's now completed, and as you can see, it took around 10 minutes to convert the 880 odd megabytes of CSV data into Parquet format. I've also since then recrawled the new Parquet data and made it available for query in Amazon Athena. So let's see what difference this now has on query in Athena. Coming back to Athena, you can see the queries. I've rerun them if you notice slightly different run times. And now you can see a second table, the FSQ Places Parquet table. So to see the difference that the change in format has, we can change the table and run that query. And now you can see it takes 1.17 seconds, significantly reduced, and scans only 14.76 megabytes. So for you as a consumer, that means reduced costs with a consumption model, because you pay for the amount of data that you scan and the time it takes to scan it. Moving to our second query, I'll quickly update the target of that query and run that again. And again, you can see a significantly reduced runtime at 0.85 seconds, and this time 0 data scanned, and the reason for that is the Parquet format and the benefit of file headers. Now that our data is queryable, I want to show you how you can do things like identification and prioritization of major markets. So here I have a query which will create a view for us so that we can look at this data whenever we want. and it's basically focusing on hardware stores. It's going to provide us information about the different stores within states and whether or not they're chain or mother and father type businesses. I've chosen hardware stores just as an example here. If we run this query, you'll see that creates a view over here on the left, and if we select these three dots and preview that, we can now see that we have a view which provides us with information about individual states, our chosen category hardware, and the details about individual chains and their presence within that state, and the number of individual shops. Here we're just looking at the state level, but using this data we could drill up or drill down to the country, maybe up and downwards towards the city, or potentially down to the individual trading venue. If I had a chain of hardware stores across the US, here I might also want to think about maybe adding information that I know about those states, how efficiently we can operate our businesses, their flexibility and accessibility for business in general, and other information such as profit margins in those regions, as they may help direct our decisions around sites. If we want to understand the complete picture when it comes to our competition in the US, we can quite quickly run simple queries against the data to understand, say, that Ace Hardware has the most venues across the US with 4747 today. So let's say we wish to drill down a little bit on the competition aspect. What we can do is create a new tab and quickly add a new query here. And here we're going to focus on a specific chains of organisations, and we'll run that query. And as you can see, we now have lots of information about the individual venues, from the venue name to the city, state, even the zip code and the geolocational information. And this is going to be useful for plotting them on a map and conducting analysis about where these businesses are located, in contrast to maybe areas that you wish to be located. Maybe that's what we do next, but before we do that, we'll need a view or a table to base it on. So I'll quickly create a new view for competitor presence and run that query. Now my new view is available. I should be able to use it in a visualization tool like Amazon QuickSight, and I just quickly want to show you that. I've moved over to QuickSight, and the first thing I'm going to do is integrate my new data set. So we'll click New Data Set here. We'll choose Athena as our data source. We'll give our data source a name. We'll click Create Data Source. We'll now get an opportunity to choose our tables from our data catalogue. So we'll choose our FSQ data catalogue, and we'll choose our competitor presence table. Here we'll edit and preview that data. Over here on the left you can see the different fields, and to make sure QuickSight picks these up as latitude and longitude, we'll quickly change the data type on those fields, and we'll add them to a geospatial hierarchy. Once that's done, we can save and visualize. We want to plot our data on a map, so down here in the bottom left we'll choose the points on a map graphic. We'll then pick up our geospatial hierarchy and move that to the geospatial field, and we'll move chain name to the colour so that we can get a picture of exactly where these chains are throughout the US. Moving closer in, we can look at an individual area, maybe somewhere like Kansas City. In reality, if you'd already got to this point, you'd likely have augmented your data with useful other bits of information to help you make decisions. So to expose that information, what we can do is add a tooltip as an example. So here we'll add a field. Maybe we wish to add our venue name, and we're going to provide the unique value, and we'll save that. So now you can expose additional fields potentially within your data set so that your reader gets more information about the particular venue. It could be a link to a website, a CRM system, or some form of index to give you an idea about whether foot traffic is trending up or down, or it's close to certain amenities, or its potential profit margin in the area. And that's unfortunately all the time we've got for the demo today. Hopefully the quick walkthrough of moving data from AWS Data Exchange through to QuickSight showed you how you can get started with Foursquare data for yourself.